Hello friends, welcome to part 2 of gamma function mathematical physics for MSc and BSc students, and today we're going to discuss uh, that why gamma of half is square root of pi. Okay, so we're going to prove this. Okay, so before we start, please subscribe the channel and share with your friends. If you like my videos, hit the thumbs up button. Also hit the bell icon so that you get notified when new video will be uploaded. You get notified. Okay, and the part 1 link of the part 1 is given in the description box. You may go through if you want. Okay, so now let's start. Now let us prove that gamma half is equal to root over pi. So we know that gamma n is equal to integration 0 to infinity x to the power n minus 1 e to the power minus x dx, right? We know this. Then according to this, gamma half will be equal to integration 0 to infinity, so x to the power n is replaced by half, so half minus 1, that's going to be minus half, right? That's going to be minus half, and e to the power minus x is replaced by not replaced, let us keep the x as x dx. So now this is equation number 1. Now let us put that let x is equal to u square. So this x to the power minus half will be u square whole to the power minus half, that's going to be u to the power minus 1, right? And e to the power minus x, that's going to be e to the power minus e to the power u square minus u square, right? So then this equation number 1 becomes like this, right? So this equation number 1 implies that gamma half integration 0 to infinity, that x will be replaced by u to the power minus 1 and e to the power minus u square, and dx will be replaced by, let me show you. So let me clean this. So if you differentiate this with respect to u, then what you will get, that dx du, that's going to be equal to 2u, which implies that dx which implies that dx is equal to 2u du. So we can write here that instead of dx we can write 2u du. That's what we can do, right? So here you see this u and u to the power minus 1, that's become u to the power 0, that's going to be 1, right? Anything to the power 0 is 1, and these two can be written outside of the integral, and then this results 0 to infinity, and here we have 2, then e to the power minus u square du. That is what we have got, right? So now you see what we can do now. As we have got gamma half, you see, as we have got that gamma half is equal to 0 to infinity, integration from 0 to infinity u to the power minus e to the power minus u square du. Now if you replace this u by x, okay, just simply replacing u by x, we can write the same result as in terms of x, 0 to infinity e to the power minus x square dx. And if you replace this u by y, then what you're gonna have, then this result gonna be like this. Replace replacing u by y, then you will get gamma half is equal to, so let me use the black ink here, gamma half is equal to 0 to infinity e to the power minus y square dy. Okay, just u is replaced by y here, and here u is replaced by x. That is what we have done, and this is equation number 2 and this is equation number 3. So now you see, let us multiply these two equations. So let me separate this part. Okay, now what we are going to do, now let us multiply equation number 2 and equation number 3. So then what you will get, so if you multiply these two, then what you will get on the left hand side, gamma half whole square, and on the right hand side you're gonna have 2 to the 4, this is 2, this is 2, 4, then integration 0 to infinity, again integration 0 to infinity, and e to the power minus x square and e to the power minus y square dx du. That is what you will get, right? So this can be written as gamma half whole square 4 integration from 0 to infinity e to the power minus x, using the laws of indexes, we can write minus x square plus y square, right? That is what we can do, dx dy. Now let me copy this result and let me go to the new slide. Let me take you to the new slide. So let me copy this. Okay, so here is the new slide. Now we're going to use the polar coordinates. Now here you see, this is the Cartesian plane, this is x and this is y axis, and here you can see that this is a point x comma y. Then what we can do, this is the line joining origin and the point, this is the origin. So in this case, if this angle is theta, then this is your x will be equal to, this x will be equal to, if this is smaller, suppose this length is smaller, we have taken this is smaller, okay, this is the point here. So then x will be equal to r cos theta and y is equal to r sin theta, right? If you use trigonometry, you will get x is equal to r cos theta and y is equal to r sin theta. In polar form, these two coordinates becomes r cos theta and r sin theta, right? So in polar coordinates, x comma y is equal to r cos theta comma r sin theta, right? So that is what we have got. So now you see, in this case r square will be equal to x square plus y square. If you square these two, that means here you see, as we have got x is equal to r cos theta and y is equal to r sin theta. So squaring and adding x square plus y square, you will get r square cos square theta plus r square sin square theta. That is what you will get. Then r square will be taken common, then cos square plus cos square theta plus sin square theta, and we know that cos square theta plus sin square theta is 1, so this part becomes 1. So we have got x square plus y square is equal to r square, right? That is what we have got here. Okay, so hope you have understood this. And here you see one more thing. In this case, this is theta x comma y. So when this theta changes from 0 to pi by 2, right, 0 to pi by 2, so we're gonna change this lower limit, we're gonna keep this lower limit as 0 and this one as upper limit as pi. Okay, we're gonna change the upper limit this infinity by pi. And one more thing, and this radius, this r, this length can be, it can change from 0 to infinity, right? So we're gonna keep one integral. Let me show you how to do that. So let me clean these things. Okay, so here you see, so we can write that 1 by 2 gamma 1 by 2 whole square is equal to 4. So 0 to pi by 2, theta changes from 0 to pi by 2. Then just wait. Bit of arrangement here. Then let us keep one integral as 0 to infinity. Okay, so e to the power minus, so this x square plus y square, that can be replaced by r square, right? Then dx dy, that's gonna be r dr d theta, right? R dr d theta. Let me write the d theta first. Okay, so dr d theta. So this is what we have got. So hope you know why dx dy is dr d theta, r dr d theta. So let me show you. So here you see in Cartesian coordinate, this is x, this is y. So this is your point x comma y, suppose, and so a very small displacement from with displacement along x-axis is suppose dx, and very small displacement along y-axis is suppose dy. Then this square, this is dx dy, this is area element, right? Now in polar form, this is y-axis. In polar form, what happens? Here you can see that this is your point, suppose x comma y, and the position vector, this is the position vector r, suppose, and this is here you see along the r vector there is a small displacement, suppose dr, right? Displacement vector dr. Also we have considered this radius vector changes its angle. So this angle made with x-axis is suppose theta now, and it is changed by very small angle d theta, right? D theta. Okay, so then you see this is the increase in dr. Now in this case, this part here you can see this arc here, you can see it will be given by, this part will be given by r d theta. We know that length of the arc is given by this is your suppose sector, this is the radius, and this is the angle in radian. Then this length will be given by r d theta, right? This length will be given by r d theta. Okay, so if that is the case, then this area, so for very small displacement we can assume this part as a rectangle, right? This part as rectangle. So here you can see, so this length is, we have got r d theta, as this angle is very small theta, and we have assumed this is in radian r d theta, and this is dr, this is nothing but dr, this part is dr, so its area will be given by r d theta dr. So that is why in polar form we can write dx dy as r d theta dr. So hope you have understood this. So just let me remove this part. Okay, so here you can see what we have done. We have written this dx dy r d theta dr. That is what we have got, right? So hope you got it. Up to this point it's clear, I think. Okay, so now let's do one thing. Again we're going to substitute that. Let us put, just wait, sorry, let us put that r square, small r square is supposed t. So if you differentiate both sides with respect to t, then what you will get, so differentiating both sides with respect to r, then you will get 2r here, and on the other side dt dr, so dt dr. So we can write that 2r dr is equal to dt. That is what we have got, right? That is what we have got. So hope you have understood this. So now then this equation, right, this is suppose equation number 4. This equation number 4 implies that gamma half whole square is equal to 4 0 to pi by 2, 0 to pi by 2, then again 0 to infinity e to the power minus r square is replaced by t. Now then you can see this r dr can be replaced by this. R dr will be equal to r dr will be equal to dt by 2, right? That will be replaced by dt by 2. So we can write dt by 2, and we have d theta. Just we have substitute here, right? So hope you have understood this. So we can write d theta. So now you see, if you integrate this part only, so one more thing, this 2 cancels, 4 gives 2, right? This gives 2. So if you integrate this part only, then what you will get from 0 to infinity. Okay, so now let me take this result, let me copy this, and let me go to the new slide. Okay, just let me go to the new slide here. So this is the last step we have got. So if you integrate 0 to infinity e to the power minus t dt, this part, then what you will get, integration of this, you will get e to the power minus t by minus 1, and we have integration from 0 to infinity, right? That is what we can have. So we can write that gamma half whole square is equal to 2 0 to pi by 2, and now this part will be replaced by this result. Okay, this result, that is what we have got after integration. Then again d theta, right? Now if you put the upper limits and lower limits here, then what you will get, so here you can see, on putting this upper limit here, you will get minus e to the power minus infinity, then minus. If you put the lower limit here, then you will get e to the power minus 0. That means e to the power 0, you can say, by minus 1. So here anything to the power infinity is 0, and anything to the power 0 is 1. So that's why we have got minus 1 by minus 1, and that's going to be nothing but equal to 1, right? So we have got 2 0 to pi by 2. Here we have got 2 to the power minus infinity e to the power minus infinity minus e to the power 0 by minus 1 and d theta, which is nothing but 2 integration 0 to, sorry, that should be pi by 2, then this is minus 1 by minus 1, right, d theta. So at the end we have got this d theta. Integrating d theta, we're gonna get theta, and we are integrating it from 0 to pi by, integration from 0 to pi by 2. And if you put the upper limits and lower limits, then you're gonna have pi by 2 minus 0. So that's why gamma half whole square is equal to 2 into pi by 2. So 2 gone, we have got pi only. Then let me go to the new slide. Okay, copy this, and here is the new slide. So this is what we have got. So now you see, as it is gamma half whole square, so therefore gamma half will be equal to square root of pi. So that's how we can prove. So hope you have understood this. Now let's go to the new part. Just soon after this video, I'm gonna upload the next part where I'm gonna explain the transform of gamma functions, different transformations. Okay, and we're gonna solve problem as well, right? And when the next part will be uploaded, that will appear at the end of this screen, at the end of this video, so you can get it if you watch the video till the end. And so thank you for watching. See you in the next video. Okay.